You are standing at the edge of the most powerful thing in the universe. Not a volcano, not a nuclear bomb, not even a star. A black hole. And here is the part no one tells you. Time itself is about to break. You know, time is the one thing that never changes. 1 second is 1 second. A minute is a minute. Your watch ticks the same whether you are standing in your kitchen or lying on a beach, whether you are on a mountain or in a valley, whether you are moving or standing still. That feels like a law, a rule so obvious it barely seems worth stating. But it is wrong. In 1915, a physicist named Albert Einstein published a theory that would shatter everything you thought you knew about the universe. He called it general relativity. And buried inside its equations was a prediction so strange, so deeply unsettling, that even Einstein himself struggled with its implications. Time is not constant. Time bends, time stretches, time slows down. And the closer you get to something massive, the slower time moves for you. This is not a theory anymore. This is not a thought experiment. This is measured, proven, confirmed reality. And it is happening right now to you at this very moment, just not enough for you to notice. But near a black hole, you would notice. Let us back up. Gravity, as you experience it every day, feels simple. Things fall down. The heavier something is, the stronger it pulls. Your body, your phone, the ocean, all pulled toward the center of the earth by a force you barely think about. Einstein looked at this and said, "You are thinking about it wrong. Gravity is not a force pulling you down. Gravity is the shape of space itself bending around massive objects. Imagine placing a bowling ball on a stretched rubber sheet. The sheet curves. Now roll a marble nearby. The marble does not get pulled toward the bowling ball by some invisible rope. It follows the curve in the sheet. That is what the Earth does to space around you. That is what the sun does to the entire solar system. And that is what a black hole does to reality itself. Now here is the part that changes everything. When space bends, time bends with it. Einstein's equations showed that gravity does not just pull on objects. It pulls on time. The stronger the gravity, the more time stretches. The weaker the gravity, the faster time moves. Near something as massive and compact as a black hole, this effect becomes extreme. This is called gravitational time dilation. Dilation means stretching. Time literally stretches, slows down near extreme gravity. And we have proven it over and over again. In 1971, physicists Joseph Haefel and Richard Keating did something that sounds like science fiction. They placed extremely precise cesium atomic clocks on commercial airplanes and flew them around the world, once eastward, once westward. When they compared the airborne clocks to identical clocks sitting on the ground at the United States Naval Observatory, the flying clocks showed different times. Not by much, billionths of a second, but measurable, predictable. Exactly what Einstein's equations said would happen 80 years earlier. But here is what most people miss. We do not need an airplane or an experiment to feel this. You are living inside this effect right now. The GPS satellites orbiting above your head carry atomic clocks. Those satellites are about 20,200 kilometers above Earth's surface, where gravity is weaker. Because gravity is weaker up there, their clocks tick slightly faster than clocks on the ground. Every single day, without correction, those clocks would drift by about 38 microseconds. 38 microseconds sounds like nothing. Without correction, your GPS position would be wrong by about 10 kilometers per day. The map on your phone would be useless within hours. Every airplane, every ship, every ambulance relying on GPS would be lost. The only reason GPS works, the only reason you can navigate to a restaurant you have never been to, is because someone programmed Einstein's time dilation equation into the software and told the satellites to adjust their clocks to match yours. Time is not what you think it is. You are living proof. Now scale that up. Way up. A black hole forms when a massive star, at least 20 times the size of our sun, exhausts its fuel and collapses in on itself. All of that mass, millions upon millions of kilometers of burning plasma, crushed into a single point smaller than an atom, a singularity. The gravity near that point is so extreme that nothing can escape it. Not light, not radio waves. Not a spacecraft traveling at 99% the speed of light. Nothing. The boundary around that point, the exact line where escape becomes impossible, is called the event horizon. That name is precise. Event horizon means the edge beyond which no event you experience can ever be communicated to the outside universe. Cross that line, and for all practical purposes, you vanish from existence. Your story ends, not because you die, but because nothing from you can ever reach anyone else again. But something much stranger happens before you cross. Imagine you are falling toward a black hole. You are in a spacecraft. Someone you love is watching from a safe distance. A space station positioned far away, with a powerful telescope aimed directly at you. As you fall closer and closer to the event horizon, your friend notices something terrifying. You are slowing down. Not because you are struggling, not because your engines are failing, not because anything is physically blocking you. Your friend watches the clock on your ship, maybe a small light that blinks once per second, and it starts blinking slower, and slower, and slower. 1 second for you becomes 2 seconds for your friend, then 5, then 10, then 100, then thousands. From your friend's perspective, you never actually reach the event horizon. You just get infinitely slow. The light from your ship stretches, its color shifts toward red, it dims, and eventually becomes undetectable. You freeze in time, you fade, you disappear into darkness. But from your perspective, nothing changed. Your clock ticked normally, your heart beat at its usual rate, you breathed, you fell. You crossed the event horizon, and on the other side was only darkness and the certainty of being pulled toward something no one can describe. That is the cruelty of gravitational time dilation. It is not symmetric. The person near the black hole feels nothing unusual about time. The person watching from far away sees time nearly stop. In 2014, a film called Interstellar brought this concept to millions of people around the world. One scene showed astronauts landing on a planet orbiting dangerously close to a supermassive black hole. On that planet, 1 hour of surface time passed for every 7 years that passed on their ship orbiting at a safe distance. The scientific consultant behind that film was Kip Thorne, a theoretical physicist at the California Institute of Technology who had spent his career studying black holes, gravitational waves, and the structure of spacetime. Thorne insisted that the science in that scene be as accurate as possible. He worked with the visual effects team to create the most scientifically correct depiction of a black hole ever shown on screen. And the math behind the time distortion, it checked out. Depending on the mass and spin of the black hole, such extreme time dilation is not just possible. It is exactly what general relativity predicts. 5 years after that film, in 2019, the Event Horizon Telescope, a planet-wide network of 8 radio observatories spanning from Hawaii to Spain to the South Pole, stitched together to function as an Earth-sized virtual lens, captured the first real image of a black hole. The target was the supermassive black hole at the center of Galaxy Messier 87, about 55 million light-years away from Earth. The image showed exactly what Einstein predicted over a century ago: a dark central shadow, a bright ring of superheated plasma spiraling at nearly the speed of light. The size of the ring, the shape of the shadow, the way light bent around the event horizon, every detail matched the equations. Every measurement confirmed that spacetime near that darkness behaves exactly the way Einstein said it would. And every detail confirmed that time, near that darkness, moves at a different pace than time here on Earth. Now think about what that really means. If you could somehow survive near a black hole, if you could hover just outside the event horizon for what felt to you like 1 year, and then somehow escape and return to Earth, you would find that decades had passed here. Perhaps centuries, perhaps longer. Your friends would be gone, your family would be gone, your entire world would be changed beyond recognition. Cities would have risen and fallen, languages would have shifted. Every person you ever knew would be a name in an archive if they were remembered at all. Not because of time travel, not because of magic, because of gravity. Because time is not a river flowing at the same speed everywhere. Time is a local experience, shaped by the mass and speed of the world immediately around you. The twin paradox makes this concrete. Take 2 identical twins, send one on a journey near a black hole, keep the other on Earth. When the traveler returns, the traveler is younger, not by minutes, not by hours, by years, by decades. The universe does not reset. There is no undoing the gap. The difference is permanent, written into their bones and their cells. Near a black hole, 1 year of your life could equal 1,000 years of someone else's. You have spent your entire life treating time as the one fair thing in the universe. Everyone gets the same 24 hours. Everyone ages at roughly the same rate. Time is the great equalizer, the one resource you cannot buy, borrow, or steal. But the universe does not care about fair. Time belongs to gravity, and gravity belongs to mass. And the most massive things in existence, black holes, own time in ways you will never experience standing on the surface of the Earth. Every second of your life, every moment that has ever felt ordinary, has been shaped by a force you cannot see, bending a dimension you cannot touch, at a scale you cannot imagine. Your clock says one thing. The universe says something else.